in the first of T? Yes. And what is the production rule we are expanding? Ft prime. Push it in a reverse order onto the stack will be T prime and F. Okay. Now, still we have look at is ID. Is ID in the first of F? Yes and yes. Then we are going to what kind of production rule we are talking about. Here, F can expand it into ID. All right. So it means we can directly replace the F on the stack to be ID. So now we're having a matching ID. They are all terminal symbols. ID matches ID. It means we can pop the stack, advance to the next input. Now you can see the next input is multiply symbol. And ID is here. ID is being popped. And T prime. T prime is the one we are dealing with right now. T prime is multiply symbol is in the first of T prime. And yes. And what is the production rule we are going to use? We'll be consulting this table and Ft prime. Push in a reverse order onto the stack will be T prime, F, and multiply symbol. Okay, now we're good here. So multiply symbol is matching to the multiply. They are all terminal symbols. Match, pop, and advance. Okay, so pop and advance. Good. Now we're good. But now we're coming to a question. Top of the stack is F, and look ahead is plus symbol. But plus symbol is in follow of E. It means it's some error going on. It's not matching to our grammar. Something went wrong. So something went wrong, we have to come back to this table. What exactly wrong? All we see is a sync. A sync error. It means we have to give the user telling them, we cannot have this symbol right here. It is not against our grammar. This error we are storing someplace in your implementations. But sync is telling you what exactly the action we are going to perform next. The sync, once we have sync, we are going to decide which one we are going to. Are we going to advance to the next input or pop the stack? Sync is telling you, pop the stack. That's the decision we're doing. So here we have decided sync is popping. So F is being popped up from the stack. So what do we have here? T prime is the one we are working right now on the stack, on top of the stack. And look at here is the plus symbol. Okay. So in the multiply symbol and the plus symbol, and we know just by consulting this table, we know T prime is newable. But newable does not making all the sense. We have to consult this table to see, okay, T prime and plus symbol, we see, oh, T prime can be expanded into epsilon. Epsilon means directly popping that non-terminals from the stack, as you can see, it changes. T prime has gone. And the only thing left on the stack will be E prime on top of the stack. And the E prime and plus symbol. Is the plus symbol in the first of E prime? Yes, it means we can further expand E prime to be something else. But what is the rule we are talking about? E prime and plus symbol. Then we have this rule, plus T E prime. Push onto the stack in a reverse order. It will be E prime T plus. Now we have plus symbol and plus symbol. Are they matching? Yes. And then what we are going to do? Pop and advance. Okay, pop and advance. Great. Now we have what the current on top of the stack will be the T, and the look ahead is ID right now. So look at it and ID. Is ID in the first of T? And yes. And then we have to know, okay, we have some production rules to apply. So what is the production rule? T and ID. That's the one we are looking for, and push them onto the stack. It will be T prime and F. And now we are saying, okay, ID is the one we're dealing with. F is the one we're doing. ID is in the first of F. It means expansion. Expansion based on this table will be F is ID. Now we have ID is matching ID, pop, advance. Okay, now we have what? T prime and dollar symbol is our lookahead. And T prime is the one, and T prime is nullable, but nullable does not make sense. We're coming back to this table to see, okay, T prime and dollar sign can be having a production rule to be epsilon, empty. Empty means pop the stack. And how about E prime? Similar idea. E prime can be pop because it has E prime to epsilon. Pop the stack. Now we have dollar sign and dollar sign. It means what? Acceptance. That's the last step we're dealing with. Does this explains your question? What is happening? We have some errors, how we recover from the errors. Now, and then the question coming up was how many errors we have developed in this example? 2 errors. Are we going to report the 2 errors directly to the user? Yes, yes. We are going to report those errors to the user at one time, 2 errors. Unlike your homework 3, whenever the errors you are dealing with will be reporting 1 error at a time, and the most the first error at a time. Okay, now what you have to understand is non-recursive predictive parsing. So up to this point, we have focused on an error recovery in a non-recursive predictive parsers, where the parsing decisions are driven by a table and a stack operations. In that design, the panic mode was implemented using the sync and scan, and to let the driver to like pop the symbols or skip the symbols to continue the parsing. The same principles will apply to a recursive predicted parsing or recursive descendant parsing parser. But the mechanism looks kind of different. And because each non-terminal is implemented as a separate function call. And when an error occurs, the current function cannot rely on a table. Instead, it must discard the input until a synchronizing token is found. So one often could be a semicolon, a right parenthesis, or keyword that marks the logical boundaries, and then return the control back to its caller. That is our recursive predictive parsing. This process will prevent the one local syntax errors from cascading multiple like recursive calls, and the panic mode is therefore essential in recursive descendant parsing design because it allows the parser to recover from the mismatches gracefully and continue analyzing the later parts of the program, producing multiple and meaningful error message rather than halting immediately. Okay, that is the only idea you want to consider. Remember is the panic mode. Whatever the error recovery here we are talking about in this class is we are going to produce all the errors to the user. Okay. Now, coming to the implementation itself. So before we writing a recursive descendant parsers, we must compute the first and follow set for each non-terminal. It is exactly the set we are dealing with previously. So we don't have to waste our time here. Exactly the same. But here, we also want to construct a predictive parsing table, which we know is very useful for us to consult which expansion rule we are going to use or not. So unlike before, this table is getting rid of the sync and scan, okay? Now we translate the predictive parsing table into the actual recursive descendant functions. So each non-terminal becomes one function, and each row of parsing table corresponding to a switch statement inside that function. So what we show here is T and T prime on this part, and the function T handles the term if the token is identifier or left parenthesis, and it calls the function f and followed by T prime, and which is exactly the matching to T and FT prime. That's grammar we are matching. So for the function t prime, it manages the continuation of a term. When the lookahead is multiply symbol, it consumes multiply symbol, it consumes, eats the multiply symbol, and calls f, and recursively calling the t prime again. Otherwise, if the lookahead is a plus symbol or right parenthesis or end of file, it will apply epsilon. Epsilon means nothing has been changed, nothing being expanded. So this structure just directly mirrors the grammar. So what's the beauty here is this approach is that the processor controls flow follows the same shape as the grammar. It is human readable, modular, and easy to extend with error recovery such as panic mode or synchronizing tokens. Now, what do you have to understand here? So you may see let's say, a question in the final. It would be what you are implementing right now in homework 3. What is its type? Recursive parser or non-recursive parser? What's that? Yeah. It is recursive. Why it is recursive? Because we are implementing a function for each non-terminal. And you have already seen that statement is calling statement recursively in that implementation in a pseudocode. Okay, do not get confused. It's recursive. Now, you may see another different question in your final will be why and what are the beauties of recursive parsing comparing to non-recursive parsing? I just talked about it. Yes. Oh, it's modular. Human readable. We have one more. Easy to implement. Human readable is easy to implement, of course. And last one. Extendable. 3. Human readable, extendable, modular. Why is that? I think all of you here have taken the course, which is object-oriented design. And we have a very good understanding about object-oriented design. What is that? Or are you still taking that? You have done, you have completed that. Is that right? Object-oriented design. So let's talk about object-oriented design. Why we want that concept in our implementation. It is human understandable. Why is human understandable? One object is representing something. It could be car, right? A car can be having a wheel, having a like windows, having a doors, and having front bumper and back bumper, etc. Now defining the attributes of a car, right? But what is the functionality of the car? It can drive forward, it can reverse, it can be turn left, turn right. That's the functionality of a car, right? That's called human readable. Once you read this functionality, you know, okay, that's defining a car. What's the attribute? You have all kinds of attributes as the local variables. What is the functionality? We know that functionality. Okay, how about extendable? That's coming back to the object-oriented design about inheritance. We can inherit that object to be extended to a certain level. Could be we can define SUV, SUV having a larger size. We could have a sedan, it's have a smaller size. And we could have a sport car. We have a luxury car, etc. That's called extendability, right? How about modular? Even though we can separate this like cars into different other objects, could be bicycle, could be plane, could be train, they could all be modular, right? So that will be, I'm connecting all kinds of ideas back to your object-oriented designs. And here, why we want the recursive parser, exactly the same reason, okay? Now, we have built and run a recursive parsers, and we need to make it resilient. But for now, I want to stop right here as it's getting close to our end of class. So for whoever is coming to the Zoom sessions, thank you for coming, and I will close up the Zoom sessions. Okay, have a great day.